Welcome to this XDK2MAM video tutorial. Today I'll be guiding you step by step through the process of connecting Bosch's XDK110 device through Wi-Fi to an Mqtt broker and set up a Node.js server that will fetch the data from the broker and publish it to the Tangle using Masked Authenticated Messaging or MAM. So let's see what we'll be using today. XDK Workbench. This is an Eclipse-based IDE. If you don't have it installed, you can go to XDK.io. In the Downloads section, find the version that suits your OS. This software is essential to import the code and then flash it to the XDK110. You will also need to have Node.js installed. You can get it by entering nodejs.org and downloading the version that suits your system. If you want to know whether you already have Node.js installed, you can type the command line node -v. If it returns a version number, then it is already installed. The git command line is not mandatory, but it's a handy tool, so you might want to install that as well before we begin. The other thing we'll need is an Mqtt Broker. This is a service that will take our data and then make it available for other authenticated users. In this case, we'll enter cloudmqtt.com and create a free account here. Once we are logged in, we can create a new instance. For this example, the name will be XDK Tutorial. We'll use the Mqtt free plan, and then the XDK Tutorial tag. Now we'll create an instance. Once it's done, we can click it to see the details like the server we'll be connecting to, etc. But we still need to create a topic, because you can have many topics on the same Mqtt server. For this, we need to add a user with a name and password. This is all necessary to be able to send the data from the XDK110. We scroll down this page to create a topic, and we'll use the account we just created. The topic is gonna be named XDK Topic 1, as it appears here. I'll provide read and write access, and then add this topic. The data from this topic will have to be incorporated into the C code before it's flashed to the XDK110, and we will also use the data on the Node.js code. Once we have all these tools, let's continue by heading to the XDK2MAM website and into the section The Code. In here, you'll find different solutions to send the census data to be published in the Tangle. Today, we'll be using the Mqtt package. So, what is Mqtt? The name stands for Message Queuing Telemetry Transport, and it's often referred to as Mosquito. It's a publish-subscribe-based messaging protocol that's very well known and widely used in the IoT world. It handles messages over TCP/IP protocol. We'll be relying on the Wi-Fi connection to send the data. And keep in mind that this is less flexible than, say, the HTTP microSD card method, because the data of our network and the Mqtt broker will be hard-coded in the device once we flash it. So we get to the GitHub repository through this link. Then copy the repo location and do a git clone. Once that is complete, a new folder has been created in our computer, and it's called XDK2MAM. Inside it, there's folders for the different methods we can use to connect our device to the Tangle. Within the Mqtt folder, we can find the C code, which we will flash to the XDK110 in order to have the device send all its data to the broker. And there's also the Node.js code that will be in charge of getting that data back from the broker and publishing it to the Tangle. So, the next step is to go to the XDK Workbench, then go into File, Import, Projects from Folder or Archive, then Directory, and browse to the folder we just downloaded. Into Mqtt, XDK2MAM-C, accept, then click Finish. Once the project is imported, we need to include our SSID and Mqtt broker info. So we go to Source and double-click on Mqtt-H. Now we have to scroll down to lines 34 onwards, where we must enter our Wi-Fi service set identifier, our SSID, our Wi-Fi password. Then, as we just said, we must provide the Mqtt Broker data. You can find this in the Cloud Mqtt website under Details. So this is the server name, and we have to copy and paste this as well as the port number. Then we do the same with the user and the password. We can also set a name for the device. This is very useful when we use several XDK110s to be able to tell them apart easily. The last value we'll need to edit is the topic name. So in Cloud Mqtt, under Users and ACL, we can get our topic. You can see it right here, so we copy and paste it there. We have to save these changes, and now we are ready to clean and compile the code. In the Project Explorer window, we right-click and then Clean Project. Once that is done, right-click again and select Build Project. This will take a while. The compilation process ended correctly. Don't worry if you get some warnings, that's normal, as long as it states that the compilation was correct. The code is now ready to be flashed to the XDK110. So next, we plug the device in. As you see, it's recognized by the XDK workbench, and we are ready to flash the code to the device. As we wait for some moments, keep in mind that as soon as the device gets the code, it's going to start sending messages to the Mqtt Broker. And here it is, the first dataset sent from our device. It will continue sending data every 30 seconds because it's instructed to do so by the code. We'll now have to go through the steps of retrieving that data from this broker and publishing it to the Tangle. So, in order to do that, we'll have to access the Node.js folder from the command line, XDK2MAM, Mosquito, XDK2MAM-Node.js. Now we type npm, which stands for Node Package Manager -I. And this is going to install all dependencies needed for the XDK2MAM solution to work. So you may get some warning or notice, but as long as we don't get any errors, we can run it. What we need to do now is edit the server.js file inside this folder. This script will need the broker credentials in order to retrieve the data and publish it to the Tangle using masked authenticated messaging. So we'll edit this script, and as you can see, we'll have to provide username, password, host, and port. All this you can find in the Cloud Mqtt under the Details tab. Password, host, and port. Next, we need to use an IOTA full node. If you don't know which to use, you can go to iota.dance and choose one of the nodes available there. Make sure proof of work is checkmarked, and then enter the node data in this section of the script. Adding the topic name is essential for the process to work. Once again, we copy the name from Mqtt Cloud. Lastly, you must always use your own seed. Remember, the seed must be exactly 81 characters long, and it must be comprised of uppercase letters A to C, or the number 9. So in this example, we'll change the last 5 characters like this. This is your channel identifier, and your data will be on the same channel as long as you use your own seed. For example, the seed that is set by default in the code is meant as a placeholder. If you use it, your data will be published alongside a lot of data that might have already been published using that seed. So you want to make sure you use your own seed. Now we'll return to the command line and run node space server.js. This script is going to retrieve from the Mqtt Broker the feed that the XDK110 is publishing, containing all the census data. And once it gets that feed, it's going to start publishing it to the Tangle. The code is set to continue doing so every 30 seconds. So we have to wait for a few moments, and here it is. This is the data from our XDK110 being published to the Tangle. In order to check these datasets are being decentralized properly, we'll have to go to the tangle.org, go into Services, then into MAM decoder and copy the root from the console and paste it here. Then click Decode. And here we can see the datasets that are being published to the Tangle. As you can see, the data sent from our sensor is displayed here in trytes, JSON and TXT. So, we just sent the XDK110 sensors data to the Tangle using the XDK2MAM Mqtt package. The datasets are now decentralized and unchangeable. And this is it for today. Thank you for viewing this XDK2MAM video tutorial. For more information and resources, go to xdk2mam.io.